Good morning. I'd like to introduce David Litfield. David specializes in searching for new threats in databases and web applications. He has lectured for both the British and U.S. governments on security agencies on database security and is a regular speaker here at the Black Hat Conference. Please welcome David. Thank you.
Right, sorry. Tim's already started, where is he? Okay, so thank you everybody for coming. It's going to be a strange talk today in the fact that you're going to get two of them depending upon how time goes. You see, this talk is probably going to last about 25 minutes, so I've got another one to do with Oracle patching to back this one up. So they're both sort of fairly limited ideas, but they're interesting enough to talk about them, but not for a complete hour. So a couple of administrative bits before we actually start. If you shake my hand and I grimace in your face, it's because I broke my little finger a while back, and I was actually splitting my dogs up from fighting. Anyway, it keeps on getting crushed, so if I offer you my left hand, if I remember to do that, please don't take offense or anything like that. So, moving swiftly on. SQL injection and data mining through inference. Well, most of us in this room probably know what SQL injection is, and to a large degree SQL injection has been beaten to death. But I think this provides a slightly new twist on it, so that's why I'm have to talk about SQL injection again. So, for those that don't know, we'll quickly cover what SQL injection is. It basically allows me to insert my own arbitrary SQL into a web-based application, well, not even necessarily a web-based application. It allows me to inject into an application my own arbitrary SQL and have a back-end database server execute that code, that SQL for me. So, just a show of hands, if you're not embarrassed to do so, does anybody here not understand SQL injection? We're not looking for, so as long as everyone's got a basic handle on it, that's cool, we can move on from there. What's interesting actually is a quick history of SQL injection. Where did it come? You know, buffer overflows just didn't appear overnight, for example. Someone actually sat down and said, hey, wait a minute, we could do X, Y, and Z with that, you know? So it's the same with SQL injection, of course. So, Christmas Day, 1998, FRAC 54 came out, in which RFP, Rainforest Puppy, writes an article called NT-Web Technology Vulnerabilities, and it's the first discourse on SQL injection, although the term SQL injection is not used at the time. Then, in February 1994, we see an Alaire advisory go out the door where basically multiple SQL statements can be embedded within the application-defined query. 3 months later, RFP, we see again with Matthew Ashley, they release an advisory on the NT ODBC remote compromise and so on. The real advance in this area came in 2000 actually, when RFP hacked PacketStorm. Sorry, Tim, what was that? No, it's cool. By the way, if anyone wants to interrupt or say something, feel free. Okay. And then 2000, like a year and a half after, the horse had bolted kind of thing, that's when I started understanding that, oh, well, this is really quite interesting. So I actually presented in 2000, wow, that's a long time ago, at Black Hat. Chip Andrews no, Chip's not around today, actually. Chip Andrews is the first recorded case of actually using the term SQL injection that I know of. That might not be correct, but I did a lot of searching for it. So Chip, if you're out there, you can be credited with the invention of that term, I think. Then came remote web application disassembly with ODBC error messages. That was another thing I did at Black Hat, that basically we could deconstruct a web-based application by looking at the error messages that were generated and so on. And I presented that at Singapore. January 2002, Chris Anley from NGS Software releases advanced SQL injection. That sort of leapt the technology forward again. 2 days before this, actually, Kevin Speck released his paper. But, sorry, Kevin, if you're in here, there were a couple of mistakes in there that sort of took away from it somewhat and made Chris's better in that regard. So no offense intended, I'm just being factual here. Chris, because he loved it so much, then released more advanced SQL injection. And that introduces time delays. Now, time delays is encroaching upon what we're going to be talking about today, inference, which of course we'll come back to. Cesar Serrado released an excellent paper. Actually, he's going to be talking here on SQL Server and Oracle and the difference in technology and culture between Oracle and Microsoft. I think that's going to prove to be a really interesting talk. He basically introduced methods of using functions like OpenRoset to do various interesting things. Then Ophermeyer and the other guys from, I think it's not SPI Dynamics, can't remember, I'm sorry, did blindfolded SQL injection, which was again a massive leap forward in terms of the attack technology. Up until that time, people were like, well, if they can't get the data out in the web page, they can't get the data, so we're safe. So people weren't actually looking for this kind of thing. That's what's so interesting about all of this, is when a new way of attacking something is introduced, people think, oh, now I'm going to start building robust defenses against these problems. In late September, Sanctum Inc. released their take on blind SQL injection that introduced, it was of course, like both of them were working independently and they both came to the conclusion it was just Ofer got his one out before Sanctum. And then last year at Black Cat, OX90.org released Squeal, which used some interesting methods. So let's get down to the business of what we're actually talking about. There are three ways of mining for data through SQL injection: in-band, out-of-band, and inference. Those are pretty self-explanatory, but I will go over them. An in-band attack is where the data is included within the web response itself. For example, we might have a bookstore that says, allows you to search for books by a given author. So we can say, give me a list of books by Charles Dickens, and also dump a list of usernames and passwords for me too. So we're getting that in the web page itself. So there could be a well-rendered web page. That was a bit of a tongue twister. Using things like union selects and so on. Or we could build error messages. Sorry, is this mic is causing, like, it is, sorry. Maybe I should talk quieter because I've got a mic. Right, is that better? Right. Sorry, by the way. Okay, another way of doing it is through error messages. You can construct your query in such a way that all the data is actually returned within the error message. But essentially that's still an in-band attack where, we are using the same channel, i.e. we connect to the web server on port 80 and the data is coming back on port 80. Out-of-band attacks. Data basically from the database server is retrieved via external means, other communication channels. For example, in Oracle, we have UTL HTTP .request. It's a procedure that basically allows us to send out a query via the back-end database server. So we are creating a new communications channel. OpenRoset, the thing that Cesar Serrado introduced, we can cause that to connect back out and drill data to us, XP SendMail. Another interesting one is actually using DNS queries through NSLOOKUP to get data out over UDP port 53 as well. So inference attacks. Well, what do we mean by that? Well, at the core of the inference attack is the question. If I drill for a tiny bit of data, i.e. literally a bit, let's say I'm looking for the first bit of the first byte of the first username in the database. Is that a binary 1 or a binary 0? If it's 1, we take one action. If it's 0, we take another action. Chris Anley's time delay mechanism essentially used this. So what he's doing there basically is declaring a buffer here, declare @s varchar, that he's basically saying here's a buffer, and then he's selecting into that buffer the data, in this case DB name, the name of the database, and then checking using these bit and operations here whether we are dealing with a binary 1 or 0 for the first bit of the first byte. You see the ASCII substring @s 1,1 and then we use the power function to get that information out. So if it's greater than 0, if it's 1, we wait for 5 seconds. We call wait for delay. So what we can determine is if the application hangs for 5 seconds on the back end, then the bit we're looking at was 1. If it doesn't hang, if it returns immediately, then we are looking at a 0. So we can infer from the application hanging whether we are dealing with a binary 1 or 0. And then what we do is increment the ASCII substring aspect. We get the next byte and next bit and so on. So we've already just spoken about time delays. That takes time. If we're saying wait 5 seconds for each, or potentially wait 5 seconds for each bit, assuming an average distribution of 4 bits which are set within a byte, then we're going to be waiting 20 seconds per byte, which takes obviously a long time. So time delay, whilst it introduced the idea, Chris could have gone so much further with it, I think. So one thing we could do is generate 200 and 500 responses. Okay, we can do that with the SQL. We can do response variation. And here's a wildly silly example. Using the mailing features of the back-end database server, I could send an email to HP support saying, please get in touch with me about my modem problem, and here's the reference number. Or, if it's a binary 0 instead, send a mail to Microsoft and say, please get in touch with me about my printer problem. So if I get a call from HP saying, well, we're calling up about your modem problem, then I know that the binary 1, sorry, it was, that the bit was set to 1 and so on. So it's a wildly silly example, but you see what can be done through inference here. You know, we are not limited by anything other than the imagination. So we actually do this, we achieve this. Before why are we doing this? Because time delay works well with MySQL, with the benchmark function. The benchmark function essentially says, benchmark this really big number, and that in itself causes a delay which we can then use. With Oracle, we can, not Oracle, with SQL Server, we can of course call wait for delay. But there's nothing really interesting within Oracle or DB2 or Infomix that allows us to cause these delays and so on. Or reasonably, anyway. So this is one thing we're trying to do, is come up with a generic way of using inference to drill for data that's going to work on all database servers, basically. So the case statement within SQL allows us to do that. We say, when the condition is met, do one thing, else do another thing. Quite simple, really, okay? So what we're looking for here is we need to build a query that's going to compile fine if we're generating error responses on the web server, like a 500 response as opposed to a 200 OK response. What we need to do is build a query such that on the way through, it's fine. When the query's parsed, it's fine, but when it's actually executed, it's going to generate us an error. So looking at this, you know, select case when condition, then 1, else 1 divided by 0, end, okay? That, when it is, it's syntactically correct. The database server will quite happily parse that. When it comes to execute, if the condition is not met, when it attempts to do the 1 divided by 0, that's going to cause a divide by error, you know, exception, and that is passed back to the database server, to the web server rather, which causes a 500 internal response. So you see what we're doing here. If it's 1, we just swing on through and we get a 200 response. If it's 0, we're causing the web server to send us back a 500 response because an exception occurred on the database server. So this works well on SQL Server, Oracle, and DB2. MySQL returns null if you do a 1 or a number divided by 0, which, you know, we can work around. The Infomix ODBC driver returns a 200 response, even on any kind of error, so that's quite annoying. Well, annoying in terms of attack, but good in terms of, well, actually, it's not good in terms of defense because, you know, we can achieve this in other ways anyway. So sometimes a response code might be 302, which is fine because we can still differentiate between the responses and so on. But the major drawback with this particular way is it leaves a large number of internal server error responses, 500 responses in your log files. And if you're looking at your log files, which you should be looking at your log files, you are going to start questioning, why am I getting all these 500 responses? If you're not questioning that, you're in the wrong job. App environments like PL SQL will return a 404 instead, which is an indicator that, again, that something's going wrong. If your web application is good and tight, you should never have anything other than a 200 response, with the exception of maybe 302s if you use redirects on your site and so on. If you start getting things like 404s or 500s or things like that, then you need to probe deeper as to why you're getting it on, why this is going on. So we can do inference through response variations instead, and this will avoid giving us 500 internal server errors, or 404s or whatever. And what we're doing is we're sending a parameter in, and we're splitting that in it, and then rebalancing it in such a way that when the response comes back, we can actually differentiate between the two. So as an example of this, we take NGS software and we can split it in various ways. In SQL Server, we would use a plus. In Oracle, we would use the double pipe concatenation. Another way of doing it is do a subselect, returns R, and separate the two. Or down the bottom, we have, again, for numerical situations, 1 plus 1 is the same as 2, or 1 plus subselect, returns 1, and so on. So when it comes to dealing with various application environments, each of them have their own quirks and foibles and so on. Cold fusion management is one of the more interesting ones in which we have to develop interesting ways of defeating. For example, double quotes are converted to ampersand quote. Sure? As it's sorry. Ampersands are converted to ampersand amp, and so on. And single quotes are usually doubled up as well. So invariably what happens when you're injecting into cold fusion applications, it's invariably within a numeric field. And PHP can often double up quotes as well in certain. Again, looking at other aspects of application environments, rather than use things like angle brackets, which we know are munged by things like, cold fusion, we can use between X and Y. But it essentially achieves the same end. So rather than use ampersand and the XOR operator, we can use, if C is greater than A, then bit is not set. If C is less than A, then bit is set. We can basically come up with variations on these that mathematically are different, but eventually lead to the same result. And rather than using things like a capital A, use tr bracket 65 or char 65. That 65, by the way, is obviously the ASCII number for capital A there. Sorry, this thing is causing loads of problems. What, on the nipple? You would like that, wouldn't you? So can you guys still hear me? Good. Okay. So if we're dealing with string data on SQL Server, this is the query we come up with, essentially. This will work pretty much, unless there's some strange filtering going on that's bespoke or custom to that application, this is guaranteed to work in any particular SQL injection area. So I'm just going to go back a bit, and what I mean by this parameter splitting. What we're doing is essentially putting in our query within, let's say there's a search page like, right, I'm just going to take this off. We're running out of time already. Right, okay. Assume there's a search page on an application that allows us to enter a search term. And that's one of the SQL injection. Rather than tracking onto the end of that, we can split that and put our actual stuff in. So here is an example of that. Let's say that the search term is different. We would go list butyl, B-I-C-K, on one half of the single quote, and on the another name for it. But not predicted because that's not predicted. So we would then put the ends on the end. That was not intended. So you see what we're doing there? We're basically splitting up the word Dickens with this. Okay. So what's going on here? You can't hear, no? Can we get this mic sorted, please? Right. Right. Sorry about this, guys. And girls, sorry. Okay. So we have a subquery which we get the first byte out and the first bit and XOR it and use between and so on. That XOR we can change, by the way, for why am I pointing at the screen? You can't see what I'm pointing at, sorry. Yeah, I'm losing myself, that's why, you know. Okay, so where that says keep talking. I'm not going to kill anybody's ears this time. So the subquery, that data we are interested in, replace that where it says sub-query there, okay? It's a sub-select essentially what we're putting in there. For example, select ATAT version on a SQL server or whatever, or select password from DBA users where name equals sys, and so on. Whatever data we're trying to drill out basically goes in subquery. The substring function there, we can specify what byte of that return data set we're interested in. So in the first request, we're obviously interested in the first byte. And when we write a tool to do this, we increment that to 1 to 2 to 3 and so on until we've got the whole of the data out. The ASCII function then converts that, and then we XOR that. You know, the ASCII converts it to a number, which we then XOR. And if it's between 0, and then we do the ASCII thing all over again kind of thing, then we've got a binary 1 as opposed to a binary 0. And if we have a binary 0, we do the 1 divided by 0, basically, which is going to generate the exception, which is going to cause a 500 response. Oh, you can do the same with we can do the same with numeric data. I just forgot to add it this morning. Oracle, very similar situation. We have using the case operator again. This time we use the bit and operation, which is the Oracle way of doing this. Doing bit operations. Again, we principally have the same. We have the subquery embedded within the substring, which allows us to extract the particular byte we're interested in. We then convert that to a number via the ASCII function and do our wonderful stuff and work out whether we've got a binary 1 or 0. String data, slightly different. The notes for this will be up on the Black Hat website because we're running out of time and my voice is now beginning to annoy me. I'm not going to read over that, but essentially, you can, if you want to get it off the Black Hat website, you can have a play with it. MySQL, again, we can come up with a very similar query using ASCII, substring, and subquery, and so on. And string data, we do the same. Infomix, now there's a difficult one. Infomix doesn't have an ASCII function, right? So what we have to do is basically go through the whole 255, ASCII values and basically say, if it's the number, if it's the letter A, return 65. So we have to have a portable ASCII function and we embed that within there. So with Infomix, what we're actually doing is having a case statement within a case statement to actually get this information out. And again, with string data. And DB2 has problems as well with bit operations as well. So on this particular part of the talk, are there any questions? Sorry about, if you've not got half of it, I understand because of this microphone situation. Are there any questions on this particular aspect? Because I know a lot of it was missed out because of the feedback and everything like that. No? Sweet. So, well, the risk mitigation is your standard SQL injection prevention stuff. For example, sanitize input, use parameterized queries, and so on. And, sorry, in the absence of that. I'm going to repeat the question, don't worry.
Is there anything that you could think of outside of that would mitigate something like that? In other words, pausing output, obviously replacing your 500 errors, 200 errors, customizing the error return code. Outside of that kind of stuff,
well, yes, you could, but that would only stop one. Sorry, the question was, is there anything we can do in terms of preventing the... By the way, for those that are leaving, we do have another talk. If you're not interested in this one, that's cool, by the way. The question essentially is there anything we can do to mitigate the risk of this? And whilst there are things you can do, for example, always return a 200 response, that just means I can't do the 200, 500 one. But I can still do it in other ways. So really the risk mitigation strategy here is use parameterized queries and sanitize your input and so on and so on. Build a secure web application. Sorry, sir? Right. On a forensics basis, that will tell us that something went on. Okay. Right. So okay. You're right. If your website has low-based traffic kind of situations, then yeah, you might be able to do that. But if you're servicing 100,000 hits per second, kind of, it's really difficult, you know. And when a spider comes along, when Google comes along and spiders your site, are you under attack? You know, but you're absolutely right. You can set thresholds for these kind of thing. Like this is now looking like an attack, and especially when you start incorporating things like logs and that at the same time, real time, you can start saying, I'm being attacked. What data did they already extract before I realized I was being attacked kind of thing? You know, if it's like the sys password, then that's problematic, you know, or George W.'s like credit card. He probably doesn't have a credit card, actually. It's probably all paid for by. So Oracle patching and knowing whether you're patched or not. So why is it important? Well, if you're performing database security assessments, we need to know this information because, one, we need to be able to mitigate the risk. NGS ourselves, we needed an accurate method for determining whether people are properly patched and so on. One, because we needed to build NGS Squirrel effectively, and Oracle has made mistakes in this area. How are we doing for time? So in August 2004, Alert 68 came out, which was a mega patch. There were a lot of complaints at the time because there was a lack of visibility in terms of what was going on with that patch, you know, which is why we now have the critical patch update with its associated risk matrix. This is the vulnerable component. It's a high risk issue. Install the patch and so on. The tool used to patch Oracle these days is known as OPatch. So we spoke about some of the Oracle patches being broken before. Quickly go over those. Cesar Serrado and Esteban found a SQL injection issue within DBMS CDC. I subscribe and subscribe. The problem itself was actually in the Java classes that this PL SQL package relied upon. Now the patch fails to load the new Java class. So whilst they ship a new Java class, that fixes the problem. The patch fails to load effectively. So one is still vulnerable to the attack, even though you've installed the patch, you think you're secure, you're not, okay? So Oracle sent out a fix for this, which turned out was broken too, so they had to send out a fix for the fix. Basically, the difference was they suggested using DBMS load Java, whereas load Java, the command line utility was the best way to go. It actually loaded the new Java classes. So another example is CTXS dry load validate statement. This procedure essentially takes as its input an arbitrary SQL query. Grant DBA to public would work in here because CTXSys on 9i is a DBA, and we can run arbitrary code, arbitrary SQL as CTXSys. On 10G, the code is still there. It's just CTXSys isn't a DBA. However, we can gain CTX privileges, which is one short step away from becoming DBA, because it has much more powerful permissions than a standard public user. On Windows, anyway, the April critical patch update copied the fixed file to the wrong directory. So when you came to actually, doing the post-installation steps like running the SQL scripts, it just never got picked up. If you had installed like the August patch or the January patch beforehand, you would be fine because you've already got the patch. But if you had gone from like the base software and just went straight to the April patch, then you would still be vulnerable to this, even though you believe you are not. So how OPatch works, okay? Within the patch itself, we have a directory, etc, and a subdirectory config. Within there is a file called actions, and that describes the actions OPatch is supposed to take in terms of copying files. And the actual files themselves exist in a directory called files, and for each component of the database, we have a directory. For example, the core part of the database, the RDBMS, has a directory called the RDBMS. Post-installation of that aspect, we have a bunch of SQL scripts that need to be run. Once it's all done, the inventory is updated, and this can be found in the Oracle Home inventory, contents.xml, comps.xml, and basically has a list of bugs that have been patched. But OPatch fails as often as it works, essentially. So we can't rely on reading the inventory to tell us whether we're patched against something or not. I mean, it's better than it was before. Don't get me wrong. This OPatch thing is light years ahead of where Oracle was, and they need to be commended on that. Patch verification, the system I've come up with basically is to compare the expected versus the actual. Very simple. So for each patch that comes out, critical patch update, we always see new objects being created, which we can look at. And we can take signatures of the old versus new packages, i.e. those packages which have been fixed, those vulnerable things, we can take signatures for that. So let's look at the new objects aspect. The April critical patch update creates a package called OWA match. It's part of the part of the web toolkit, the PLSQL web toolkit. And so if we say, does this component exist in the database server with a SQL query of select name from all objects, object name from all objects where owner equals sys and object name equals OW match. If we get a record set returned, we know the April CPU has been installed. January, there's a whole bunch of procedures that I created. Whilst the packages themselves, DBMS, CDC, DPUtil existed before, the valid schema didn't exist, and that was all part of patching some problems within the DPUtil package. So now they're checking whether it's a valid schema before passing things and so on. But we can use that as information that the January CPU has been installed. New for old. Oracle encrypts most of their PL SQL packages and procedures. Now, because of the way the encryption works, If we take the string ABCD and encrypt it, we get a completely different ciphertext. If we change one byte within, the plain text, the output of the encryption is entirely different. So we can use that to observe whether we're dealing with a vulnerable package, because we know this package is vulnerable, so we take the signature for that. We know this one's been patched, so we take the signature for that, check which one exists in the database server, and we know whether they're vulnerable or not. We can ascertain whether the patch has been installed. So, sorry, using the same slides, as you can see. The process of doing this is you check out the OPatch actions. What is OPatch doing this time around? We record the creation of new objects. Basically, we grep for, create or replace, and record that. Actually, we can look for drop as well, because a number of these CPU's critical patch updates drop objects as well. We record signatures for new packages. So if we see a new package, or not necessarily a new package rather, if we are seeing a package being updated, we can take the new signature of that and record it. So this gives us an expected end state. Once we apply the patch and we attempt to confirm that end state, if it does not meet what we expected, then we know there have been failures within the patch itself, which is why we came up the other day with these iSubscribe problems and so on, essentially. So that's just messing up again. That is very quickly a simple way of doing patch verification on Oracle. So, any questions on that one? Yes, absolutely. There's a white paper to go with it as well, but I'm not going to read the white paper to you. No. But I'll pass it to Jeff, and he can put it up on the site. Any questions at all? No? I have a bunch of books from Marcus's and Kevin's first course. Remember, we spoke about that book. If you see Dave Sr., the really old guy in the corner, sorry, not the really old, just see my dad in the corner, and he can give you the books. Yes, sir? Because, yeah, sure. Why would I use this as a technique for getting access to data when I could use another one? Well, yeah, if you can get it in other ways, you wouldn't have to use this. But if you have a login page that says, the SQL on the back end is, select select star from user table where username equals user-supplied input and password is user-supplied input. You tend not to get any information back from that. It's either succeeds or not. So you put your single quote in, and you get an error come back saying, there was a problem, please contact the system administrator, okay? We can't use that particular instance of drilling for data. This is what blind SQL injection is, without getting any data, without being able to use an in-band attack or an out-of-band attack. What can we do? And we can use inference. And what's more, we can use it in any scenario. Anywhere where we can do SQL injection, and there's, if there is nothing weird going on in terms of if this special character is in the thing, do X, Y, and Z, and a standard, SQL injection kind of problem, whether it be on a login page or a search page or whatever kind of page, we can always use inference attacks. That's why this is such an interesting area. Is that okay? Sweet. Yes, is that 5 minutes? Okay, we've got 5 more minutes, so we can either go for an extended coffee break. Yep, sure.
Any particular tips on evaluating criticality of local patches?
Yes, read the patch, the patch matrix. The other one is they are all critical. That's why they're called critical patch updates. And I'm not meaning to be facetious by that. They are all critical, essentially. Say again? Absolutely, yeah. Well, obviously that's limiting the exposure. But whether your exposure is limited or not, you're still vulnerable. So all it takes is one person to get there, kind of thing, you know. So.